Kathleen, are you a member of this firm?
Yes.
You're not.
I gotta leave.
Right now. All in favor of?
I'm a member. Stu Tate.
You're good. I think it's starting. January meeting for the RARC. I don't see anybody here that's a visitor, but if there is one, you need to sign.
Hey, Rick, could you move back so we can see you?
Do you really want to?
Unfortunately, yes.
Okay, here I am in all my glory. All right, no visitors tonight. So why don't we see if there was any old business that we need to talk about? Okay, how about, are you ready for the treasury report, Ken?
Yeah.
Let Ken might give the treasury report.
Okay, let's see if I can see it where it's supposed to. Hopefully. Okay, we started the month with $21,683.32. One of the members had a donation of $15 for us. We had 22 renewals for $484 and 5 new members for $110. So $609 came in. We had to, on our website, when you do the renewal form or membership form or any of the other stuff, it's called Ninja Forms. That's $199. So that went out. And then the ultimate win grant for the D-Star repeater upgrade, $2,246.18. The good news, that's basically about half of what the hardware actually costs. He worked a real good deal. He got $1,000 off on a discount. He sold the old equipment to somebody in California who paid for the shipping. And so
we have to do it in return.
send him the hardware. But so that was real good. And then PayPal for all of those memberships and renewals charged us $34.02. So we ended up the month with $19,812.46. So not too bad. And that hardware upgrade, one of the other things that if you did not realize it, you don't have a D-Star, don't worry about it. You can use regular FM and it goes out. It doesn't go out as D-Star, but at least you could be heard on the repeater. So
With the tone of 74.
yes, with the tone at 74 point, as all of the repeaters are in the area. I have 2 new members. Robert Nynum, who's in advance. KQ4NBK. Second one, I have to pronounce this very carefully. Sherweiler. Okay. Thank you. Who's a tech. So he's the other one that is joining. Appreciate you helping me through that. Can I have a motion to accept the membership?
Motion to accept.
So the second one.
Oh, I'm sorry. Yes, I do.
I'll second it, KO4RNT.
And so vote, all those in favor? Aye.
Aye.
You're an official member. The only other thing I have that I would like you to. We have somebody who has a new call sign.
Who is it?
Come up here so everybody can hear you. Ah,
Don't be shy.
Good evening. Now Whiskey 4 Lima Echo Whiskey, no longer WD4 FMG, which is quite a mouthful in SSB contact. So Whiskey 4 Lima Echo Whiskey, yay! My mission.
Story.
Lord?
Yeah.
Oh,
You can call him down.
remind me.
Who's calling the store?
Okay,
Yes.
so it was Lou Best. Lou Best was a Richmond resident. he and I were in the same DX club, DDXG. Lou was sick when I joined the club, so I never met. But Lou's wife comes to Donald's board meeting every month. It's a big mess. So, she encouraged me to go for Lou's calls. So I do have a former, well-known Richmond Ham's call.
That's a good.
That's the story.
Which, you know, is to be your initial.
And it's also my initial. Thank you.
Thank you, Lauren. All right,
Sorry.
any new business anywhere? Go ahead, Tom. So you have to come up
I
here.
wonder if you
Tom,
would
have to
like
come up
to
here.
give your spiel.
Okay.
Feel.
You have a spiel.
May I?
Yeah.
Switch it, but
Love it. Hello. My side. Hello, can you hear me?
Yeah.
I hear you.
Yeah,
Yeah? Okay, I'm Kathleen Adams, Kathleen Tamayo Adams. As many of you know, my father has passed away and left me with the most amazing, ginormous collection of priceless, wonderful antique radios that any of you have ever seen. And what I want to do, rather than sell them or throw them in the trash like my father always warned me every day not to do, I would like to create a space for us all to go to and play with radio. I said, it's a good idea. So I've talked to a commercial real estate agent who says that the least money I would need is $500,000. And this is for like a shack in a not great neighborhood. And it goes up from there. And I've also talked to people at Stony Point Fashion Park who are offering $300 a month a rent a month for like a little thing, a kiosk. I don't know who, I don't go there. Probably you guys don't want to go there either. Terrible neighborhood. So what this building could be a place for people in the community to get together, particularly us, ham radio operators. You all would be welcome to come in at any time with the radios, eat your breakfast, do whatever you want to do. We could have classes there from local schools. We could have a tower to do like radio contesting. Yes. So my goal now is to fund this. Now, I'm not just some guy who's like, hey guys, can I have $1 million? I have my collection to offer, and also I'm willing to put up no more, I'm telling you, $100,000 from the sale of my house, because I have to sell it anyway, and my dad gave it to me, and that's what I have. So I know this is a group of really, really smart people out there too. And they're lawyers and scientists and doctors right there.
Yeah.
No, I don't want your money. But what I do need is all your smart minds to get together and help me figure out how we can avoid throwing this thing in the trash. Because right now we have, and I hate to do this, you guys, but I have a storage pod coming tomorrow where I'm going to begin moving the things that I think can withstand being outside in the weather.
Are you moving into John's house?
Yes, I've been living there since before he went on hospice.
So that's why you need to create space for you.
Yeah.
Okay.
Not only that, but what's the point of having all this awesome stuff in my like living room?
Because
I know, but you could have to look at it with the low cost stuff. Yeah, yes.
Just a thought, have you thought about asking the science museum?
Oh my God.
Yes,
Yes, ma'am. So with the consulting with several of the members here, they poo-pooed that idea because, and especially other museums as well, like the Smithsonian. Historically, what happens is you give them your priceless, wonderful treasures, and they get a new curator in, and the curator says, poo-poo, we like cameras instead. And so they go throw all your stuff out or sell it for who knows what, and I don't know. I would like it to be in our family, meaning you people, because you're the people who like radio. Yeah?
Yeah.
Yes.
The Virginia, the library of Virginia, It's not the Richmond Library, it's a state library in Virginia. Has accepted several, I guess, grants of equipment and stuff like that, and they keep them on display. They rotate the display. This is for fly fishing and famous flies, kind of like Jimmy Carter and people like that. And the people that wrote that book didn't have any place to put these hundreds of flies, so they donated it to them because they would take care of it, but also make it available to the public, so they might be somebody considered.
That is a thought.
Partially funding it if they don't have any space.
That's a That's a great thought and a great idea. Do you know anyone who could touch base with? I've sent thousands of emails and delete those. I've talked to the WC whatever club. I hope they're not watching. You know, the big one up north. I've talked to a guy who started a museum in Maine because he has a friend who is like a 90-year-old guy who had an air shop of radios. And so he's gonna put it in like a hipster neighborhood as a storefront. He's running it as a corporation and just gonna have tax write-offs for his profit. Starting a nonprofit is really hard.
You reached out to ARR.
I haven't heard back from them. I probably need to.
Comment.
Hello,
Well, sure, but then we can't live at the radio.
Well,
Have we tried
question.
those people
That's a good idea. That's close enough to us.
not quite so close, but I know the Williams law, they even have a boat anchor breakfast, which I guess means.
Comment.
They know about, and they know about
Comment.
equipment of the SPM.
Yesterday, that's our jam.
You could have a 24-hour breakfast spot called Ham and Eggs.
That's a
Nobody.
good idea. I love
I
that.
know,
You
I'm
can
public
make your
spot
wives or
real
whatever, like go to the family. Yeah, so yeah, again, you guys are like the smartest people. Looking at you.
Comment.
And I'm not asking for your money because I know my dad would be like, what?
we
Money
did
running.
that, we're playing equipment before.
No,
We just looked at it.
yeah.
So
I don't like it.
it's a paradigm shift, I guess, you're thinking. I mean, that sounds like a big, I mean, even if you had a lot of money, it would be nice,
Mhm.
but to have all those radios with antennas hooked up and stuff like that would be quite to have all of them so they could work, would be quite a,
Do you think they would all have to work it?
if you want to go in there and play with the different ones. But, I mean, if we didn't really,
Well, something could be done.
yeah, but you could put it.
Comment.
Yeah, you can maybe check out a radio.
Pardon me?
I said, maybe you could check out a radio, bring your radio home.
Well, that's a different story, but
So I'm just trying to make a comment.
actual music, even that's they are now, the radios don't work.
Hmm,
You can look at it, be glass. I mean, that would be,
That's not fun.
that would be something way on out.
Yeah,
There's more than we have now.
Yeah.
Now, I like the idea of checking out a radio to play.
be fine.
But some of John's radios should be behind glass.
I understand.
Yeah.
And
More stuff, all of that.
anybody flavor.
So I set up a thing. Oh my gosh, I hope I'm not taking up, whose presentation is it? I don't know.
It's not, what's that for?
Okay, I'm super. So I set up, like a temporary display at the Chesterfield Historical Society, and I was going through, my dad, right before he passed, gave me like this
A pain in
very
the ass.
condensed version of the history of radio, which I was gonna like throw together, make a PowerPoint, have like pictures of which radios matters for which thing, and it's just like a huge undertaking, and the display can only be for like 6 months and starting next year, and we just need like a space.
And maybe the county, they break some nerves somewhere, maybe. Folks might say, well, I have a storefront or I've got this
Yeah.
space. That's a possibility. If you need a PowerPoint, you already have an online presentation that John developed for his equipment. So you could just use that.
I was thinking that, I did
Yeah.
think that up.
Must have been thought a little bit
Train museum?
Train museum guys didn't seem that excited.
No,
They said that
yes.
Yeah, they said that they didn't have enough space.
Comment.
So, okay, so my immediate need is tomorrow, we're gonna be working on moving the stuff. So I'm taking names, emails, phone numbers, whatever, whoever wants to come over and move the stuff 50 feet from inside to the pod. And more importantly, I am taking names, emails about where we're gonna put the stuff. Because please don't let it just get thrown in the trash or get mold on it or rust or anything. All I have to offer is the collection and it goes to 100,000, which is a ton of money, you're paying.
Yeah. Well, if we could sell that equipment, okay, it's got tubes in it,
Uh-huh.
and some would say you probably should take the tubes out and package them. And the other thing is out in that pod, I don't know if it's weather conditioned or not, and humidity conditioned, you know, then that's not gonna be a good environment for that stuff.
And the musical instruments cannot be, and have to be in an air conditioned environment.
Oh, yeah.
But that range stuff's gonna rot and get corroded and so on, it's like anything if you put it out in a pot.
Those cabinets on those old antique radios, that stuff will split. Wood will split.
What are we gonna do with it?
I'm just saying, putting it outdoors, the physical act of moving it, if you drop it, you break tubes, which probably a lot of which are irreplaceable. I'm just, it's kind of, it almost requires someone like a curator who has knowledge of all that stuff like John. He knows what it is and what its peculiarities are, like Armin has applied some of its priceless stuff
Yeah.
that you don't want to drop.
I would also contact the Virginia Association of Museums, because there are literally maybe around 100 little museums all over Virginia that had originally at some point your problem. It's a specialized thing for some locale, and they had something and they didn't feel like a house or something they didn't want to let just fall apart.
Yeah.
And through the Virginia Association of Museums, they provide like counseling, manpower, and they also have a very strong group that's like FEMA, that if there's a disaster, they have a whole team that will go to your museum and they know exactly how to, you know, put things away and protect things that have been through a disaster or that might be through a disaster. So you really should contact them. They have some, I haven't spoken to them for about 6 years, but they're really a great group. I mean, Virginia Museum's part of it, and they have some pretty big guns there that might be able to.
Can you work with her and give her the information that she knows?
I belong to the Small Museums Network on Facebook. I put that in her collection. But that's as far as I got to the picture. All right, good point. So for the radio, maybe I'll just put.
Rats and bugs. Don't want to eat that stuff.
Yeah.
Comment.
Lots of rats and bugs.
But there's
I got one bedroom worth of storage area with all them.
excellent.
Any of the Zoom audience have any comments for Kathleen?
There were
Yes.
several people in here.
Yeah, you ignored them.
I see a hand somewhere.
Yeah.
KN4 SYE.
And for SYE, did you have some?
Is she trying to keep it? Yes, is she trying to keep it in Richmond?
Just a thought for you, have you ever tried universities?
Yeah. Who has it?
Tons of them. You're looking. into-
Because one of our club members,
California. I'm sure that-
hey, Rick,
Okay. Okay. Yeah.
He's not listening.
You mean
Nope.
Blacksburg?
Yeah, it's kind of hard.
Yeah, 200 miles. Yep. Sure. I got a store here.
Maybe you could send my email address and I'll just keep telling people. Me again.
Yeah.
Hello.
hey, Rick,
How much?
Stacy, your email address.
Yeah. Right now.
want to, like, sign up to be
Rick.
available, they can contact you.
Hello?
Hey, Bruce.
Hey, DEMAJO.
Hey Jeff, put your hand back in there and maybe they'll see it.
Maybe I'll just start yelling and screaming.
K as in
that would help out.
kilo.
Uh-huh.
D as in what?
Okay.
No, no, D is D.
D is in David,
David.
D.
E as in
elephant, echo.
M as in not.
Okay.
Monthly. Right. A as in alpha. J as in Julia, and O as in. That was silly. You guys should know the last name. At Gmail. Hey, it's mine at Gmail. Thank you.
They have space.
I don't know. You know, it's a 2,000-foot house and the radios are almost everywhere. But particularly in the living room.
He's got a floor
Comment.
to ceiling, what is it, 8-foot ceilings? Yeah. With radios everywhere. Again.
And an organ.
Yeah.
And two, he said.
The organ is a pipe chamber
We can, yeah. If I could just have that one room.
What if we built a cabin in your backyard? That's probably. I'm serious.
Hey, Rick.
I'm talking about building a cottage in the bed, would probably be less expensive.
Hey, Rick,
Can I come over? I had to look at zoning. I did talk to the agent.
But I mean, that, in the long run, building another place for you to live on your property would probably be less expensive and less hassle-free and really stuff.
Like it's.
Mike is not working, according to
Oh,
one of the people.
I am.
No, we're trying to talk to y'all.
Working over there.
The mic is working. The problem is there are people on Zoom that are trying to ask questions
going
and
in.
comment
It
and they're
should
not
be.
coming back to them.
so like any time of day, you have a lot of message me. And like.
Thank you.
Yeah.
So, does anyone have any new business?
the problem is,
Anyone in
he
the
runs a
remote-
meeting for the people who are there
Yeah.
and forgets about all the Zoom people.
Can y'all hear
Rick,
me?
you're not paying attention.
They can't hear us. That's the problem. We got a
Well,
problem with the volume in the room, and that's not a new problem.
That's.
Well, you need a mixer board with another.
We got a
Okay.
mixing board. We got all kinds of other stuff.
hey,
It's
Rick,
just not
can you hear
working
me?
right.
You switch.
Well, what I actually did before was this. Maybe.
Hey, Bruce.
That's the anyone here.
Yes.
I have a club member in Rats that their parents own a shopping center, and she can probably put John's stuff in the shopping center in a
It's
store
getting to
Yeah,
here.
it's getting
where we
there.
can have
Which
meetings and whatnot with
then
everybody
should be-
else.
Okay, so who is this talking?
This is Kane for SYE, Rats president.
Okay.
So if you want to have her email me at president@rats.net, I will put her in touch with people.
I will do that. I think
Thank you, buddy.
we have a problem. We have a problem with the complexity of the way the Zoom works to people being able to hear you in the room. I've been in the
Sam?
room and not been able to
Yeah,
hear
working.
people on Zoom. I think that's what's happening
Okay.
tonight.
This thing says it's
You
there.
need louder output.
It's getting there. so-
No, we just need it so it works.
Yeah, that's,
Understood, Bruce.
I can tell you a person who could make it work,
That's.
who is a
That's-
member of RARC. If you would talk to him.
You talking about Jim?
You want to hear me?
Jim Rubin, yes.
Anyway, yes, we have had it working before. The problem is that you have very little time to get it set up before a meeting starts. So unless you're gonna get there, it's 5:30, 6 o'clock in the evening, you're not gonna have it happen.
Well, we could get a volunteer there.
Testing.
Hey, if you can identify the volunteer, I bet we'd let them there.
Well, yes.
Is that union group that was talking,
Yeah, I think so too.
Or close.
that's people that talk to.
So let's go ahead and just have a motion to close the business meeting.
I so moved.
Second. Anyone, all in favor of closing the bid? Okay, so
Aye.
we're gonna go ahead and, I mean,
Hey, Bruce,
I think give a remote presentation.
Rats
That's
has got a
important.
winter field day, the 27th, 28th of January. You guys are more than welcome to come out to it.
I'm not sure what time.
Oklahoma State Park.
7:30. So the.
Okay. Yeah, I knew about that. We'll have to get the word out on that.
I appreciate it, buddy. Are y'all gonna do anything for the Virginia CUSO party?
Presentation. Code.
Yes, we volunteer.
How to design Yagi antenna.
Well, we have the rookie thing that we
on there.
I didn't know we could, if Rats Club and RARC could team up again like they did a couple years ago to do the Virginia CUSO party at the church.
Okay, yeah, I'll try and write this all.
Ken, can you hear me?
I can hear you guys.
You guys.
Y'all can hear us now?
Yes?
They could hear us
Cool.
before, but Waller, the president, couldn't hear you. The guy speaking.
You help
can't
us
hear
do
us.
that.
Say that I-
Okay, we're ready for the presentation.
Well, Rick,
Yes.
if you could have John DiMaggio's daughter reach out to president@rats.net if she would like to keep the stuff in Richmond. One of our club members, his mother owns a shopping center that has some vacancies that potentially we could put all of his stuff in there and do a meeting space.
Who is speaking?
KN4SYE, Rats president.
Oh, okay.
We got the president on the line.
Co-president.
I don't
Okay.
know.
That's wonderful. Thank you.
Yeah, thanks, Jeff.
Yeah, bud. Winter field day is the 27th, 28th at Pocahontas State Park. And then if you guys are y'all doing anything for the Virginia CUSO party?
We usually give out a plaque.
Yeah.
And what came to my mind, if possible, would be to name that plaque in honor of John DeMeo, K5HTZ.
Okay. Yeah, do that. I know we're doing a plaque as well, but I didn't know if you wanted to get your club, my club together, maybe at the church and do a CUSO party at the church for that weekend.
Sure. Oh, it isn't.
Virginia, what weekend is that, Jeff?
I want to say it's March, like St. Patrick's Day weekend.
Okay, I guess, Tom, what about the church availability on the weekend?
It's probably okay, as long as it's not Easter. I don't know what's going on with Easter. But we,
Yeah, we could do that, but our club has always given out a plaque for the Virginia CUSO. I think we'd like it, it'd be nice if the membership and board agrees to name it in honor of John.
If somebody needs to send a note to Kathleen to reserve space.
The Kathleen is right here. Do you want me to bring her up to the microphone? That's where Kathleen.
No, not that Kathleen. I met Kathy at the church needs to make a reservation with her if you want the space.
What do you say?
what, you tell me what time, what date, and I'll talk to her tomorrow.
All right, I'll
Sounds
reach
good.
out to Rick and we'll email each other back and forth. Kathleen, the shopping center is right there, basically at Midlothian Turnpike and Turner Road.
That's crazy. I know right where that is.
Yeah, that where the Arby's is and all that.
Yeah.
One of the Rats,
Okay.
one of the Rats club members, his mom owns, or the mother-in-law owns that shopping center.
That's amazing. Let's do
So
it.
I will reach out to him and see what kind of deals I can work, whatnot. And
Yeah.
especially with the meeting place for clubs and school and whatnot, we might be able to work something out.
That's awesome. Thank you.
No
I have a
problem.
comment.
Y'all have a good one.
Hooray. Thank you.
I have a comment.
Go ahead.
I think what would be good would be a combination of a museum and a library. A museum for the old stuff that can't be loaned out, and a library for the stuff that's current that can be loaned out. People can set up their own antennas. That way you don't have to set anything up.
Yeah.
Do it.
I
That
think
sounds
we-
like a committee problem.
About 100 years of QSP or something.
I'll support it.
We can have 2 cents.
Okay, that sounds great. Anybody else in the Zoom audience have any comments?
Yes,
Go
I
ahead.
would like to do a new business item.
Go ahead.
New
We did it
business
again.
item is
Y'all still
get a
hear
group
me?
together. Hello, can you hear me?
Yes.
Get a group together to solve the Zoom and the audio problems, because obviously in the last number of months, you have not been able to solve it.
Who is speaking?
KO4RNT.
Okay, well, you may not know the history behind all this and the effort.
Yeah,
tremendous
I know
amount of
I
effort.
don't know all the history, and
Well, I'm
that's
telling
why,
you that a lot of people put tremendous effort into this. And a couple of folks who would be here to help out with this would be Bruce, and he can't be here because of a family illness and young guy.
yeah,
There's a
but
young
it's
fellow
more
that-
than just Bruce. Come on,
I
Ken.
know that. If you listen, I'll get to it. There's a young fellow, what's his name?
Jackson,
Rick.
Will Jackson.
Yeah. Guy
No,
who's here.
Rick,
Will.
Will.
Will, on the roll, and he's been very helpful, but he could not make it tonight, but, and Ken Leidner and John DeMeo, a lot of people have put in a lot of effort in this.
I understand that,
Yeah.
but you still need.
We still need experts. And if you look out on our website, there is a request, hey, if you'd like to help out, so we have the Zoom working, volunteer. And
I did.
okay, I only got one other person, which was Will, other than Bruce and myself.
Well, other than Bruce or yourself, you get Jim Rubin, and you get enough equipment to do the damn thing right.
Okay. We just need to know what all that is. Okay?
You would,
Uh,
yes, that's
so-
true.
So fill out the form again online. I'll get an email about it. Unless you did it just today and I was not particularly looking for stuff. But yeah, we need all the help we can. We're using a borrowed camera that is something, and the cart that John built. And so we just need all the help we can. Basically, the thing that we were thinking of doing was having a meeting here at the church, bring out the card, go through the process and figure out what is causing some of these problems. Like, you could hear us for a while and then all of a sudden it went dead. Nobody changed any settings. It's just all of a sudden something happened. So we need all the help. Appreciate it. Volunteer. And then we'll be all set. So back to our president.
Well, if you don't change the equipment, it'll never get better.
We have something like 19 kinds of things. So I think we have enough money to buy equipment if somebody needs what it was that we need.
All right, I don't know whether the remote folks heard my introduction to presentation tonight. It's going to be John Fortune, W6NBC, coming to us live from the West Coast. And he's going to talk, John's going to talk to us about how to design your own Yagi antennas painlessly. So that sounds interesting. So John, if you're there, you go ahead and get going.
Okay, guys, I'm here and we'll get going here with the presentation. Okay, there we are. Turning a few things off here. Okay, you should be seeing the opening slide of the presentation. Are you?
Yes, we are. Thank you.
Yes.
Okay, good. That's just fine. All right. Well, this is an interesting topic because Yagi antennas, of course, very dominant in ham radio, and yet are a kind of a mysterious or arcane, if we use the term, meaning hidden, to many antenna, to many hams. And hams don't think of Yagis as simple devices. They think of them as pretty complex. But I'm going to show you that that's just not true. I'm going to show you how to design a homebrew Yagi easily without going through a lot of difficulty. And I'm going to give you a simple example of it. The Yagi antenna, or the Yagi Yuda antenna, as many of you may know, was designed by actually but two Japanese engineers back in 1926. It was really not designed by Yagi, but designed by the guy on the left, Shintaro Yuda. He was the engineer who actually came up with the idea of the parasitic beam. Yagi got his name onto the antenna because he was the one that popularized it or published and promoted the antenna, but wasn't really responsible for its design much. So it probably should be called the Yuda antenna, but we know it as the Yagi. It's what we know as a parasitic beam, and it's certainly a very dominant, iconic beam in the radio, not just ham world, but in the entirety of the radio world. Even common people associate the shape of the Yagi antenna with radio. For example, here are quite a number of Yagi Yuda antennas that most of you are quite familiar with, of course. Even the well-known crossed arrow beam. I have one of these for satellite work, a VHF and a UHF antenna mounted crosswise on a single handheld beam, and done a lot of satellite working with these. They work very well. And I've published a tape measure version of this beam in QST back some time ago. I forget when it was exactly. And of course, there in the middle top is a little commercial UHF beam, and on the right, of course, is probably the most common way we know beams, of big multi-element Yagi beams. And on the bottom, a couple of VHF beams there. And of course, most common broadcast television antennas are some form of Yagi when you think about them, if you look there at the bottom. So it's pretty much an iconic antenna in the world of antennas. But how does it work? I think you have some idea. Most of you have some idea how the Yagi works, but I've got a couple of slides here that I like because I like simple illustrations. I'm pretty good at math, but I don't like mathematics for trying to explain things. I like visuals. I like to see things. And I know my favorite scientist, Albert Einstein, was that way too. He was good at math, although some people used to say he was not good at math. He just didn't figure math was a way to explain anything. Math was a way to make something happen after you knew how it worked. He liked to see pictures of things, which he called mind experiments. Well, I think you'll like these couple of slides. Here's how the Yagi, or the parasitic re-radiation beam, works. This is what Yuda discovered. You take a common dipole, which is what we call the driven element in a Yagi, and you put some energy into it at the feed point there, which you see in the middle, and it radiates a wave, symbolized here by the green line. If you put another dipole, not connected to it electrically at all, you just put it in the field of the main driven element. You put it near to the driven element. It's going to pick up, because it's close to the driven element. It's going to pick up a good bit of the energy coming off of the driven element. In other words, it's going to be a parasite. That's why it's called a parasitic element. It's going to pick up and receive some of that information, some of that energy. In other words, the driven element is going to introduce currents into that parasitic element. And that parasitic element will immediately re-radiate it, as shown by the blue line. But if you make the length of that other element a little shorter or a little longer than the driven element, it will radiate it. It will shift the phase of the re-radiated signal. It will change the timing of the way the signal is re-radiated off of that parasitic element. And you notice what happens here. If you arrange the position of that parasitic element and the length of it properly, you can get the relationship which you see here. That in one direction, the two waves, the primary wave from the driven element and the re-radiated wave from the parasitic element, will be in phase, as you see it there on the right, which we call the forward direction of the Yagi. But in the other direction, if you look at it, called the reverse direction or the backward direction of the Yagi, they will be out of phase, and they will destructively cancel each other or interfere with each other and reduce the strength of the signal. But in the forward direction, they will add to each other and increase the strength of the signal or increase the gain, as we often count. An antenna doesn't have any real gain. It's only, a gain is only a matter of which way it puts the signal. It increases which way the signal is stronger in one direction or another. So you can see here in this one direction, it's stronger, therefore it has gain, as we call it, in the forward direction. So that's basically the principle of a Yagi. By changing the position and the length of the parasitic element, we cause in one direction the re-radiated wave to be in phase with the primary wave, or out of phase in the reverse direction. That's how the basic thing works. Now I found this next slide on a website which shows you all of this happening dynamically. I think it's a great slide. I'll show it to you now. Oh no, I'm sorry. Before we do that, here's what's happened though if you put another parasitic element behind the driven element. But this time you make it longer. And by making it longer now, you change the phase or the timing of the re-radiated signal. And again, you can get the same relationship to occur. But this time, because you've made it longer, you've retained the fact that in the forward direction, they're in phase, and in the reverse direction, they're out of phase. So both with a director and a reflector, you can get the information going in the forward direction to be in phase and improving the gain, and in the reverse direction, destroying the gain and producing less gain. This is the way the reflector works. By the way, if you build a Yagi, only one reflector is worthwhile. All the best results with a Yagi is with more directors. Some you've seen, occasionally you'll see a Yagi with more than one reflector, but it's not worth the powder and shot to blow it up. If you're ever going to build a Yagi, don't bother with putting more than one reflector, but more than one director is what you want if you want to get more gain. So both the director, by making it shorter, and the reflector, by making it longer, you can establish this relationship of the forward waves being in phase and the reflected waves and the reverse waves being out of phase. And here you can see it happening in this 4-element Yagi that you see up here with 2 directors and 1 reflector. And you can see all the waves in one direction are in phase, and all the waves in the backward direction are out of phase, and you're getting destructive interference backwards and constructive interference forward. And you're getting a lot more gain going to the right and a lot less gain going to the left. Hence, we say the Yagi has definite gain to the right and less gain going to the left. Parasitic re-radiation. That's the way a Yagi beam works. I thought these were particularly good dynamics. I didn't create this drawing. I just found it on the internet. Okay, but now, moving this out of the way a little bit here. I'll stop that. Both hams and even some professional engineers are afraid of Yagis. And I think this is probably kind of true of most of us. I was this way. Many hams, and again, I include myself in this group, think that I could not possibly design a Yagi. They're much too complicated. And we see all sorts of different designs for Yagis and different information on the internet about how to build them and where to put the elements and all this other stuff. And most hams are kind of like this guy on the left over there. They're terrified by the idea, and they'd never the idea of going into their garage with some welding rod and a boom and trying to build myself a scratch Yagi is kind of out of the question, because many hams think that only high-powered engineers can design a Yagi. That's completely beyond my capacity as a simple ham to be able to build a Yagi. I'm going to tell you that's not true. That's absolutely not true. Yagis are not that difficult to design for yourself. They're really pretty simple, as you're going to see here. In fact, though, you're not alone if you think this, because from 1926, when the Yagi was invented, until 1948, even professional radio engineers were confused. They designed Yagis pretty much by trial and error, because there was not much guidance out there about how to design Yagis. And to this day, for most hams, there are still no simple design rules, no sort of things you can tuck away in the back of your brain and say, oh, I know how to design a dipole, but I don't know how to design a Yagi. Well, I'm going to tell you, it's just as simple to design a Yagi as it is to design a dipole. So, and that's what we're going to look at here tonight. Fortunately, though, the National Bureau of Standards, which is today called the National Institute for Science and Technology, the same group, in 1948, conducted a series of tests right after the Second World War, because they realized that the Yagi antenna was an important antenna, but that it wasn't very well understood in the technical world. So at their two test ranges that they had, one in Boulder, Colorado, and one in Sterling, Virginia, they set up test ranges and they started studying Yagis in very great detail. And eventually they published this one report, which you can still get. Just go on the internet and search for NBS Technical Note 688. That's where I got this one. This is my copy of it. It's got 3 pages out of my copy, showing you one of their Yagis and one of the curves from it. And you can still get that report. NBS Technical Note 688 is readily available on the internet. And it'll give you everything and all sorts of curves and stuff that the National Bureau of Standards published. From this point on, we had the equations and the curves for how to build Yagis. And professional engineers have been using this report ever since. As a result, today there are many online calculators that you can use. In fact, if you've ever tried to build a Yagi for yourself, you may have used one of these calculators. Unfortunately, there's a lot of disagreement if you've ever tried to build a Yagi. If you go online and look up these calculators and look up the dimensions, you might want to build a 2 meter or a 6 meter Yagi or whatever it is, and you put your numbers in that you want to make, and you put them in 2 or 3 different of these calculators, and you're going to find you're going to get different answers, because they don't explain how they got their answers. Therefore, hams are confused. They don't know which ones of these calculators to use. And probably most hams do not have enough mathematical background to run those detailed graphs in that National Bureau of Standards report, or to work the equations. Most hams can't handle that much technical stuff, and they shouldn't have to, because they don't have to, and you don't have to. You don't have to dig into all of these calculators and all of this mathematics to design a perfectly good Yagi. It's better than 95% as good as the very best calculator and the very best high-powered physicist can create. Hams definitely, though, need simplification. when it comes to designing Yagis. And it is available, I guarantee you, because I'm going to show it to you. Surprise number one. I'm going to give you two surprises, which are going to show you that Yagis aren't complicated for the average ham. You only need 3 rules. Remember these rules. These are the rules to designing your own Yagis, whether it's out of welding rod or aluminum tubing or whatever you're going to build your Yagi out. Maybe some old curtain rods or whatever you're going to build your Yagi out of. You only need 3 rules to make a perfectly successful Yagi. Make all of the elements spaced the same. Don't get all bothered and troubled because you'll see on the web the elements spaced at different spacings, some of them closer, some of them farther apart, and so forth. Don't bother with that. That's a waste of time. Yes, you might get a tiny, tiny little bit of improvement by doing it that way, but believe me, it's tiny, tiny. It isn't worth the powder and shot to blow it up. It's much easier just to make the spacing all the same. And what's the spacing? The magic sweet spot is 0.2 of a wavelength. That came right out of the NBS report. That's in the NBS report. If you look in that Bureau of Standards report, you'll find that the optimum spacing is 0.2 of a wavelength. Therefore, don't bother with different wavelengths and for different elements. Just make them all the same. Just make all the spacing the same. Make an equal spaced Yagi with all of the elements spaced 0.2 of a wavelength. What's 0.2 of a wavelength? 300 divided by frequency times 0.2. That's easy to figure it out. So whenever you're going to make a Yagi for yourself, don't bother with different spacings. Make them all 0.2 of a wavelength. And when it comes to the directors and the reflector, and the one reflector, because you only want one reflector, more than one reflector isn't worth much. But if you want more gain, put on directors, not more reflectors. Make all of the directors and reflectors 5% longer or shorter. That too comes right out of the NBS report. That's the sweet spot. So if you're going to put directors on your homebrew Yagi, make all of them, not just one of them. Make all of them. Whether you've got one director or 10 directors, make them all 5% shorter than the driven element. That's all of them the same size. Extra directors, make them equal length and equal spacing. That's the 3 rules. Very simple rules, aren't they? Nothing difficult at all. And that's all you really need to know about building Yagis. But I tell you, if you do that, you're going to get a Yagi that is 95% or better, as good as the very, very best Yagi the most high-powered engineer can design. You're going to say that's too simple. It's not too simple. It works brilliantly well. Surprise number 2, and this was the big surprise to me. I'm going to show you 2 curves here. Where do these curves come from and what is it? Well, this comes from EasyNeck, the antenna modeling program. These are 2 curves that I got from EasyNeck. I'm a big EasyNeck antenna modeling fan. And what are these 2 curves? I went on the internet and I gathered for myself all the calculators that I could find for designing Yagis. And I did a 3-element Yagi with my 3 simple rules. Equispaced, 0.2 of a wavelength, 0.2 of a wavelength apart, 5% different in length. That's the 3 rules that I used. And that's the red curve that you see here. I plotted in EasyNeck. Then I went on the EasyNeck and I found all the calculators that I could find. And I put the same sizes. I made the same Yagi with the calculator. And I took their results and I made a composite of them. That's the blue curve. How much difference is there? Well, in fact, my little three rules actually was superior to a composite of all the calculators I could find on the internet. So why trouble yourself with going on the internet looking for these calculators when those 3 simple rules will beat the calculator's hollow. By the way, this is an azimuth plot, which means looking down on the top of the antenna from the top, the bird's eye view. These are radiation patterns of the antenna. Those three simple rules will give you a Yagi that are at least 95, in most cases, 98% as good as the most detailed Yagi that the most high-powered engineer can possibly build. All those little tiny adjustments, tapering the elements in front, spacing them slightly differently, all of that is fine. It might give you a tiny few percent different, but it isn't worth the effort. And the station at the other end is not going to notice the difference. So the simple design steps, if you're going to design a Yagi, here they are. Get yourself a boom and mount a driven element on it and tune it up. Use the simple standard formula, the 95% of the half wavelength. Put a driven element up on a boom, whatever kind of a boom you want to use, and get it resonant, get it tuned up with your antenna analyzer so that it works on whatever band you want it on. Then add a director and a reflector and use the rules. Use the three little simple rules. Make the director 5% shorter, make the reflector 5% longer, and make the spacing 2/10 of a wavelength. In other words, use the three simple rules. Then match the whole antenna together. In other words, get a low SWR by putting some matching arrangement at the feed point. There are several different types of matching, and I'm going to show you some of them here in a minute and show you the one that I favor because it's the simplest one. And get the antenna matched, and which will require a little bit of tweaking on things, but get the thing matched, and then once you've got the good SWR, then trim the elements a little bit equally. Take a little bit off of all of the elements until you get the frequency right. Now, notice that I do it in that order. I do the SWR first and then the frequency second. This is a general rule for tuning up all antennas, not just Yagis. Most hams will think, oh, you would want to tune the frequency first, don't you, when you're tuning up an antenna? No, you want to tune the SWR first. Why? Because if you tune the SWR first, it won't change much when you do the frequency. But if you do the frequency first and then do the SWR, the frequency will go way off. So you're much better off in tuning any antenna. I don't care what it is. Tune the SWR first, then tune the frequency, and you might need to tweak the SWR a little bit after you're done, but it won't move very much. So this is the general rules. Mount yourself a driven element, 5% shorter, 5% longer on the director and the reflector. Put some kind of matching at the feed point until you get a low SWR. Wow. Then trim the elements of the Yagi until you're on frequency. Then maybe if you want to, go back and adjust the SWR a little bit. It's a simple process. It's really that easy. My wife, by the way, found this picture someplace, and I just love it. So I like to use it on my presentations. And no, the book didn't say Yagi design on it. I just put that on with the Photoshop. Now let's look at some matching methods for a Yagi. There are three common matching methods that you find on Yagis: the gamma match, the J match, and the hairpin match. I have my favorite. It's the bottom one. It's the hairpin match because it's the easiest. But the J match is a good one too as well. And the gamma match. The gamma match is favored by commercial builders, but it's very difficult for the home builder to build gamma matches. Therefore, I don't like gamma matches. And J matches work pretty well, but I don't find them as easy as the hairpin match, which you're going to see. These are the three common matching ways to get the SWR and the frequency right on a Yagi. So let's take a look. You're going to see these matches as we go through this simple, cheap Yagi that I'm going to show you now. Let's look at a really cheap Yagi that you can build for yourself. And I mean, it's cheap as heck. let's look at the boom first, what we're going to build a cheap home Yagi out of, what we're going to make the boom out of. Now, a lot of hams would think, oh, I know what to build the boom out of. I'm going to go to the hardware store and buy myself a piece of PVC pipe. That'll make a great boom for a Yagi. Wrong, Johnny, tell them what they didn't win, as they say on TV. Why? Because a round PVC boom, although a perfectly satisfactory boom, is very difficult to mount elements on. You can see this guy's boom where he mounted some wire elements on the boom, but then he had a terrible job holding them into the boom. So he had a lot of plastic tape to try to hold it in. Difficult to hold elements into a round boom. And here you see, here also you see the J match. The J match is a good way to match a Yagi. It's half of a folded dipole. If you know anything about a folded dipole, you know that a folded dipole has a much higher center point impedance than a standard dipole. So by making half of the driven element of a Yagi as a folded element, and then feeding it where I show you there between the center of the antenna and the end of the folded element, you get a much closer to 50 ohm match. This is a pretty good way to get a pretty natural match to a Yagi. And that's the J match. This is pretty common method. You'll see it on a lot of homebrew, and it works pretty well. It's pretty difficult though to adjust it, to get it to to adjust the SWR. You pretty much take what you get with the J match, although it pretty naturally comes pretty close to 50 ohms. It'll probably get you under 2-to-1 SWR, which is perfectly okay. Rectangular booms are much better than round booms. And that's why, of course, commercial manufacturers tend to go with rectangular booms. This is a commercial beam, and you can see, because you can put the elements through the boom and put screws to hold things down. And rectangular booms are generally much easier to handle than round booms. That's why the commercial manufacturers use them. Unfortunately, they're difficult for hams if you want to build a Yagi at home to find rectangular aluminum. Now, if you've got a good metals dealer in town, you might be able to find rectangular aluminum, but most hams have just ordinary hardware stores, and you're never going to find square aluminum tubing at most hardware stores. You might find round, but you're not going to find square aluminum. So that's why I don't recommend. Recommend actually aluminum tubing if you're going to build a cheap Yagi. You also see here a gamma match, and that's why commercial manufacturers like gamma matches, because once you get them built, they're a great match. They adjust very well, and they're very convenient, but they're very difficult for hams to build. So I don't like gamma matches at all for home construction. I'll show you what I do like here in a minute. It's the hairpin match. Now here's what I recommend for cheap homebrew Yagi, at least as far as the boom goes. You'll also see the J match here, which is okay. I don't recommend the J match myself. I recommend the hairpin match, but this is what I recommend for the boom. A wooden boom is perfectly acceptable for building a small VHF, UHF antenna. They work very, very well. A little bit of urethane varnish on some finished 1x2, and you've got a boom that works excellently well. And it's very easy to mount elements on it. You just drill a hole through the boom, put a little silicone sealant on it, shove the element in there, and it's in there for good. Very, very durable way to mount it. And it's a perfectly good boom to mount elements on. Readily available, inexpensive. So I recommend the boom here in this particular example. I don't particularly like the elements he used here, but I'm sure this Yagi worked perfectly well. Here's an interesting character. She's a fashion designer in New York City, but she's also a ham, quite an active ham, Diana Eng. She has published quite a few antennas. And as you can see here, she's used a piece of 1x2 lumber to build a satellite tracking antenna, like the beam that we often use. It's got a 440 beam on one axis and a 220 beam on another axis. I like the way that she uses wire nuts to keep you from poking your eye out, which is quite good. In this case, she's using aluminum tubing. She's also using the J-match to mount it. You can see the connectors on a wooden block there to feed the J-match. That's a nice little beam, pretty well designed, using a wooden boom and a J-match and some aluminum elements. I don't know whether it's aluminum tubing or aluminum rod. I suspect it's aluminum tubing. And she's here on a walkway in New York City. Okay, let's take a really cheap Yagi example. Again, and I got the misspelling there with a semicolon instead of an L. Beg pardon for that. The elements. What do I suggest for elements if you're going to build a really cheap homebrew Yagi? Most hams, if they're going to build a homebrew Yagi, would probably, if they didn't use curtain rods or a welding rod, would probably use one of these two materials. Some soft copper or aluminum tubing, or solid house wire. These are obviously pretty obvious choices to build a homebrew cheap Yagi out of, but I don't recommend either of these, frankly. They both work fine, no difficulty, but they're not particularly durable. They easily bend and get bent out of shape pretty easily, particularly the wire. But they work fine electrically. They just aren't very durable. In fact, you can see there. Now, here's the wooden boom that somebody made. And I'm sure this Yagi worked fine, but the wire that he used here for the elements, that's not very durable. I think you'll thoroughly agree. Maybe if he used heavier wire, it might have been a bit more durable. But even if he used heavier wire, it still wouldn't be durable, really very durable. Here's what I recommend for the elements in a homebrew Yagi. You can go on the internet. Amazon has them. You can buy a whole stack of these. This is just a picture off of Amazon. These are driveway snow markers. And I'm sure living back there in Virginia, you know what snow is. I don't have any idea what snow is out here in California. In fact, my wife, when she saw me ordering these driveway snow markers, said, "What in the heck are you ordering snow markers for?" We live on the coast of California. We don't ever get any snow here. I said, you know why I'm ordering. I'm building an antenna, because everything I do is for building antennas. But they make wonderful elements for building homebrew antennas, particularly Yagis. They're very, very durable, very, very strong. They're fiberglass, plastic fiberglass rods, very strong, very bendable, very durable. And what do? You cover them with aluminum foil. We all know that RF, any kind of alternating current, particularly high frequency alternating current, does not run uniformly through a conductor. It runs on the skin because of skin effect. The magnetic field inside of the wire pushes the current all to the surface and forms a thin skin. So the inside of an RF conductor isn't necessary. It could be a pure vacuum for that matter. It isn't needed. So the inside of RF conductors, like the elements in a Yagi, don't have to be metal. They can be nothing at all, or they certainly can be plastic driveway snow markers or fiberglass rod. And so I like to make homebrew Yagis out of fiberglass rod with aluminum or copper foil tape on the outside. They work just as well as solid aluminum or solid copper or copper tubing or copper wire. So foil covered fiberglass rod is a much better material to make Yagi elements out of. You can also use bicycle flags. Probably go down to your local bike store, or even to Walmart or wherever you shop regularly, or Amazon, and you can buy these bicycle safety flags. They're 1/4-inch fiberglass rods. They make excellent Yagi building material, and they're relatively inexpensive. A couple of these rods, and you can build a good sized Yagi with them. And you just cover them with self-adhesive aluminum tape. This is some that I got off of Amazon. On Amazon, you can get this self-adhesive aluminum tape in all sorts of thicknesses and all sorts of widths, or you can probably buy it at your local hardware store, at least in up to 2-inch widths. And I recommend you buy a thick variety. It's like this 4 mil. That's what you get off of Amazon. If you go to Amazon and look for 2-inch by 4 mil tape, you can find it quite readily. Why 4 mil? That's the necessary thickness to give you good skin depth. And here's the design of this little simple Yagi for 2 meters. It's an article that's coming out. In fact, it's already out on the Air magazine. If you get that from the ARRL. And here's the design of this particular little 2 meter Yagi. The elements are exactly as I said. They're 2/10 of a wavelength spaced, which is 16 inches apart. The lengths of them, the driven element is calculated by pretty much by the classical formula for the length of a dipole minus 5%, and then the driven and then the reflector and the director are 5% longer or shorter than the reflector. And there's the hairpin match, which we're going to deal with here in a minute. And there's a U-bolt and a ballon. The ballon is just in this case 1, 2, 3, 4 turns of the coax wrapped around the boom, wrapped around the wooden boom, and then there's a U-bolt, which is pushed through one of 2 sets of holes, either drilled horizontally or vertically through the boom. So you can mount this Yagi either vertically or horizontally on the mast. So it's you can mount it for horizontal or vertical polarization as you wish. An easy little design. Here's the match that I like. It's a very simple matching. It's a very simple matching device. What is it? Well, it's a short piece of open wire transmission line. What happens when you bring the director and the reflector of a Yagi close to the driven element? You lower its impedance. Its natural impedance in free space is about 72 ohms. But when you bring the director and the reflector near to it, it drops the impedance. Anything you bring near an antenna reduces its impedance. So it goes down in impedance to something around 35 ohms or something like that. If you put a director and some directors and a reflector on a standard driven element, it'll drop the impedance some. And it will also make it somewhat capacitive. Why that happens, I'm not sure. So what you need is a little inductance across the feed terminals of the Yagi with directors and reflectors. And all Yagis do this. If you just build a Yagi and put a director and put directors and a reflector on it, it'll be lower than 50 ohms and slightly capacitive. You need to cancel out that capacitance so you get a good match. And you do that with this little hairpin. This little hairpin is a shorted piece of open wire transmission line. If any of you know anything about transmission line, you realize that a shorted transmission line that's shorter than a quarter wavelength is an inductor. It's inductive. So all this little wire here, as this little hairpin, is a little inductor. You could use a little coil if you wanted to, but it's much easier just to use a hairpin because you can make them much easier than a coil. So what I simply do if I build a Yagi like this, I simply just take out my pliers and I bend the little loops in the end of a piece of wire, and I just bend myself a little loop here, and that's all I did to get a good match on my little simple cheap wooden Yagi, and I had to bend 2 or 3 of them till I got a good match. And it was that simple. I didn't have to do any calculating or anything else. There's no formula for figuring this out. I just did a little wire bending. And I had to do it 2 or 3 times until I got a hairpin that gave me a good match. I didn't have to get a perfect 1-to-1. I got it down to about 1.3 to 1 or something like that. And that's perfectly okay. And this is what I found it was necessary. This is what I found worked perfectly well. A little hairpin match, which was 2 inches wide and 3 inches long. And it went right over the screws in the driven element, which has a gap in the middle inside of the boom. So how does the hairpin match? Well, as I said, a dipole in free space is 72 ohms, but you put the director and the reflector on it and it drops to 35 ohms minus J some number of ohms. In other words, a little capacitive. So you need a little inductance to cancel it out. The hairpin, which is a little shorter transmission line, is a little inductor. So it's a little inductive. And you just bend a couple, 2, 3 of them until you get enough inductance until you cancel out that minus J that's naturally there. And also the combination of the J and the R there, which is the 35, ends up at 50 ohms. It works very, very simply. It's an easy match to make and build. And here it is. You can see it on the boom here. There's a hole drilled through the driven element, either side of the boom, 2 inches apart, because the 1x2 is not 2 inches wide. It's about 1 5/8 wide. So I've got 2 screws there through the driven element. And by the way, there's a gap inside of the boom, which you can't see, which is about 1/2 inch of the aluminum foil tape taken off of the fiberglass elements, which creates the gap. And then there's some 632 screws which go through the foil covered driven element, makes connection. And then you can see the little ballon, which is 4 turns of Mini 8, or you can use RG58 if you want, and which just makes a perfectly good ballon to choke off it's a 1-to-1 choke ballon there to isolate the feed line. And you can see the U-bolt, which is a U-bolt sufficient to fit a piece of 2-inch pipe. And you can mount it either horizontally or vertically, depending upon which set of holes you use. And I recommend you mount the thing on a piece of PVC pipe and use it as the mast, or you mount it on a short PVC nipple and mount the nipple down a bit lower with a double mast clamp onto a metal pipe. Although this will work fine directly on a metal mast. And that's all you do. That's a simple little antenna. And here's the finished antenna, and it works very, very well. And it'll last very, very well out in the weather with a nice coat of urethane varnish. It'll probably last years out there in the weather. And the elements are held into the boom with a little bit of silicone sealant, and piece of cake. As you can see, the feed line is just tie wrapped to the mast or to the little nipple of the 2-inch PVC nipple. Other bands, 220, 70 centimeters, perfectly easy to do it the same way. Here's my 70 centimeter version of it. I did have to make a little change for 70 centimeters. I tried to do it in the same way I did it for 2 meters and put the ballon and the U-bolt right behind the driven element. But unfortunately, the U-bolt created some parasitics. So I couldn't put the U-bolt between the driven element and the reflector. So I moved it behind the reflector, which got it out of the pattern. And I also moved the ballon behind the reflector. And this worked fine. For 220, you can leave the ballon and the U-bolt between the reflector and the driven element. You can use the same design for 6 meters as well. I use just a pipe nipple. This is a 2-inch piece of pipe coming down, and then I mounted it on you can mount it on a mast. And those are standard double clamp TV mast clamps, although the antenna can be mounted directly on a metal mast. So takeaway, remember the 3 sweet spot rules. You need to remember these rules if you want to build a Yagi. Space all of the elements the same, 2/10 of a wavelength apart. Don't bother with these different element spacings that you see with the calculators. Make all of the directors and the reflectors the same difference in length. Don't taper them. It's a waste of time. Yeah, you'll get a tiny, tiny bit of improvement, but so little that it isn't worth the powder and shot to blow it up. Make them all 5% either longer or shorter. Make the reflector 5% longer and all the directors 5% shorter than the driven element. Equal length, equal spacing. Simple. That's not complicated. No calculators, no math, no equations. That's all you need to know to build Yagis that are at least 95% as good as the best engineer can ever design. Design tips: mount and tune up a driven element. I left the E out of driven. Sorry about that. Make a reflector and a director 5% shorter, 2/10 wave spacing. Match the feet point, and I recommend the hairpin, and then trim all the elements to tune. Tune the SWR first, tune the frequency second, and you've got yourself a perfect Yagi. No longer you need to be afraid of Yagis. You can be like this guy on the left. There is a simple method. It's not just high-powered engineers that can design Yagis. As you can see there on the right, I designed that one, and that one works as best as the best commercial one you can buy. And here's my little dog, Lolly. No, she doesn't have a German call sign. You can get a hold of me at w6nbc.com or write me email at w6nbc@gmail.com.
Okay, thanks a lot, John. Let's have a hand for John. We're running up against some bad weather here pretty soon, so I don't want to have a long time for questions, but if does anyone in the Zoom audience have any quick questions for John?
And for WLC, Bill.
Go ahead, Bill.
Thank you, John. Excellent presentation. I was curious, does the hairpin match need to change size when you go to 440 or 220 or whatnot?
Oh yes, definitely. It'll get smaller or longer depending upon the band you're on. But like I say, just get out some 14 gauge wire and a pair of needle nose pliers and just take a shot at it. Make one that looks roughly like the one you see. And then if you've improved the SWR, then you know you're going in the right direction. And then make another one. That's all I did. I didn't do any fancy calculator or anything. I just made 2 or 3 of them and I made the second one. If it was better, I kept going in that direction until it started getting worse. I made 2 or 3 of them until I got within about 1.3 to 1 SWR, and that was good enough.
Got anybody else in the remote audience have any questions? Okay, we have one in the studio audience. Come up, Rob.
Yeah, when you're tuning the hairpin, do you do that before you put the elements on or after?
Oh no, you have the elements on.
Okay. And okay. And do you lose much power with that hairpin because you don't?
No, not at all.
Okay. Well, dude, I got one question. My question is as you add more directors, what happens? If you had a 3 element, if I made a 4 element, would the impedance drop lower as I add more directors?
Surprisingly, after the second and especially the third director out there has very little effect on the impedance matching of the antenna. You'll probably find you can just hang them on there, and all they'll do is improve the gain. You might require a little adjustment to the hairpin match if you add more directors, but it's relatively small change as you add directors. So I can't answer that quantitatively, you know, with numbers, but in practice, by adding more directors, it'll only require a tiny little adjustment change in the hairpin match to bring you back to a good SWR. You might be able to just squeeze the hairpin a little bit or expand it out a little bit just by bending it outward. You might end up with a good match without even having to change because that'll change the characteristics of that little bit of open wire transmission line. Change the L of it a little bit.
Okay.
So I have one quick question. If you have your impedance 35 ohms minus J, and you put in you cancel out the capacitive reactance with inductance, wouldn't you still have the 35 ohms at the feed point?
No, it's not actually, when you put the hairpin in, it doesn't just cancel out the J. It's the vector sum of the two that it's adjusting. So if you draw the triangle, you can actually, by the hairpin is actually bringing the total impedance to 50 ohms, not just canceling the J.
That's excellent. Thanks very much. All right. I think that's, thank you very much, John. I hope you all don't get any more rain and flood stuff out there in the weather. Terrible snowstorms up in Lake Tahoe. We're going to get some rain here tonight, but we appreciate your talk. It was very enlightening, and thank you for joining us. So one more hand of applause for John.
My pleasure, and have me back anytime. I'm adding new stuff all the time, building new antennas. It's what I do in retirement now. I don't spend a lot of time on the air. I spend more time building antennas and writing articles. That's what's fun. So all the best to you guys. I'll say 73 to you.
John.
Thank you, John.
Thank you, John. Bye.
Okay, remote folks, that's our meeting for tonight. Everybody stay dry. I don't think there's any board members remotely.
Mac.
Huh?
Mac.
Are you there, Matt?
Yeah. He's in the middle.
Okay, Matt, hang in there, buddy.
Next to Patrick, actually, is where he's at on our screen. Patrick's the one that's see his top of his head.
We're going to try to have a real quick board meeting here. The rest of y'all have to sit around with you. You're welcome to. The main issue ahead for the board is we can't replace John, but another person to kind of occupy the position, and the bylaws stipulate that the director should be an immediate past president, and there aren't any immediate past presidents available. So the question for the board is,